So powerful it shifted the Earth's axis? That's what scientists say happened on Saturday when Chile was shaken by a megatremor that registered 8.8 on the Richter scale. One of those scientists is with us now, Andreas Rietvbrock, a professor of earth sciences at England's Liverpool University. He's analyzed the area in Chile that was struck by the quake. Andreas, let's start with this slightly disbelievable analysis. Although we have to believe you guys are the scientists, how does an earthquake shift the Earth's axis?
So the earthquake is redistributing the masses, so the rocks on the surface. And if you have such a big earthquake, you're actually talking about 200, 300 kilometers in length and about 40, 50 to 100 kilometer in width. So you're moving these rocks up nearer to the Earth's surface and redistributing in that way the masses of the Earth. It's like if you have watched the Olympics, the figure skating, if you look at the pirouette there, if the athletes move their arms closer to the center, they are just speeding up and spinning much more quickly.
An effective explanation. I want to ask you, though, how often does this happen? We've heard that the tremor, 8.8 on the Richter scale, made Chile's earthquake the 5th most powerful since 1900. How high do you have to get for this kind of effect to take place?
So you have to be in the high magnitude 8 earthquakes as far as I can see it. The analysis was done by NASA, and I think we are right now only beginning to understand and actually able to compute these kind of very small effects.
Now, speaking of computations, another analysis done in the wake of this earthquake shows that the day actually got shorter. And we're not talking about the day just in Chile, the day for everybody around the globe. Can you try to help explain how that happens?
Yeah, because as I explained earlier on, you're changing the rotation speed of the Earth because you redistributed the masses. Therefore, the Earth is not spinning so fast anymore, and therefore our day has changed in this.
All right, Andreas, thank you so much for joining us. Andreas Rietvbrock of Liverpool University in England explaining how the Earth's axis shifted and the day got shorter. Incredible stuff.
Well, in the hit film 2012, the entire planet starts falling to pieces and actually shifts poles after the planet's core starts going south. So you can imagine it got our attention when NASA said the catastrophic earthquake in Chile was so powerful, it knocked the Earth off of its axis and shortened the length of the day. My guest is author of Physics of the Impossible. Michio Kaku is a professor of physics and host of the sci-fi science on the Science Channel, and graduated first in his physics class at Harvard. I mean, what more could you ask for? All right, Michio, I'm not that into science. I mean, honestly, I got to be honest with you. But it knocked the Earth off its axis. Even that got my attention.
Well, first of all, no one's going to fall off the Earth. You're not going to get a shorter work week. However, the Earth did shift 3 inches off its axis, and the day was actually shortened by 1.26 microseconds.
How?
So this was a colossal earthquake. Remember that the Earth shifted 6 feet over a distance of several hundred miles, 20 miles underneath the ground. It's like a skater bringing in her arms at the Olympics. You spin faster and faster. The Earth actually contracted.
Look what we have ready to go as you talk to us about skaters.
Right.
Nancy Kerrigan. She's doing the same thing the earthquake did. But how? Okay, how? Explain to me how that move right there is like the earthquake.
Okay, as she brings in her arms, it's like the crust of the Earth contracting as one plate went under another plate. So several hundred miles of plate shifted 6 feet in the Earth, and that increased the rotational speed because the Earth contracted slightly.
Right. So what does it mean for us? I mean, are we going to sort of be walking around tilted to the left now, or what?
No, it's a very tiny effect, and however, GPS systems could eventually be affected. It's a cumulative effect. The Earth is permanently slightly off axis now.
Really? And what about the shortening of time? How does it shorten the day by a couple of seconds?
Well, instead of going 24 plus or minus hours in a day, it's off by 1.26 microseconds. It's a very tiny effect, but it builds up over time. So like the GPS system, telecommunications, or space satellites will eventually have to take this into consideration. But for you and me, it's not going to affect our daily life.
It's so incredible, though, to think. I mean, if you want to respect Mother Nature, you look at something like this, and you really do. Michio Kaku, it's a pleasure having you.
Right.
How about that? So if you had a bad day last week, you got a little shorter. Is today a little shorter, too, or was it just that one day?
Oh, no, forever.
Forevermore.
That's right.
Well, there you have it.